Okay. First of all, I will introduce the Wavesplitter. So we established in 1996. So you can see our company name is Wavesplitter. So it's a passive component. So before that, we do the focus on WDM, DWDM, and the AWG product. But after 2003, we want to become a IPO company in Taiwan. So we established a RD team for the chip side and the transceiver side in Taiwan. So you can see the 2020 and the 2021, we established transceiver module and manufacturing in Taipei and establish laser chip manufacturer in Taoyuan. And we also develop 10G and 25G. It's high speed DFB laser. And also in 2021 and 2022, we also developed a 3010 high power laser. It's the 70 milliwatt first at 70 degrees C. And in 2022 and 2024, we also developed 100 milliwatt for the CW laser. It's our global office, the headquarters in Taiwan. And as I mentioned, the transceiver side in Taipei and the laser chip side in Taoyuan. And we also have the sales office in Fremont. And we also had the Japan team. Japan is the sales office in Japan. And we right now we have Vietnam. It's our manufacturer side. We also build up the POSA, and the transceiver side in Vietnam. And China is our supply chain manager team in China. Okay. We had our core technology. We had three main application. One is the CW laser, including the chip, laser chip, and the laser chip array. It's the high power laser. And you can see the right side is 10G, 25G, 50G DWDM, laser chip. It's high speed. So we will also focus on fiber to the hall, fiber to the room. And the left side is the sensor, optical sensing. So we also develop a 5050 narrow line with DAB laser and the 6053 gas sensor DAB laser. So we have the high power and the high speed and the sensor chip. It's our core technology. It's very simple DAB laser chip process flow. So we buy the AP wafer from our supplier, and we also find the OEM to do the wafer process. After that, we in-house to do the scribe the wafer to the bar, and we do the face coating, and to do the AR, HR coating. And after that, we separate the from bar to chip. Then we do the TOCAM and the CLC to do the reliability and the burn-in testing. So I will I want to show our chip current prediction. The high power laser, we also the 17 milliwatt is in mass production. We mentioned that 17 milliwatt is in 70 degrees C, okay? And the 100 milliwatt right now with the sample evaluation. So, and because we had the laser chip, so we also use our laser chip to develop our optical engine and the transceiver. So we also had a 400G DR4 optical engine, and by the next year, we will ready the 800G 2 by DR4 LPO transceiver this year. And also we had a high speed laser chip. So we had a 10G, 25G, 50G. So we use our chip to develop our home product. So like a BOSA or transceiver. And the 5050 laser chip is we also developing right now. And I will show it's a very simple laser chip process flow. It's the wafer process. Okay, you can see the first drop is the AP wafer. Currently, we use the 2-inch or 3-inch to do the to. So we buy the AP wafer, and then we had the first mask is to do the ridge. So we use the dry and the wet etching to do the ridge because our laser chip is a ridge waveguide. Okay, so we don't use the EH structure, so we use the ridge waveguide structure to develop our laser chip. So you can see the ridge. So we use the dry and the wet etching to do the ridge. And after ridge, we use the preservation film to protect. It's a silicon nitride. And after that, you can see we use the second mask. We open the contact. And after that, we start to do the P metal. It's a type PT gold to do the P metal, and then we do the annealing, and then after that we do the gold plating. You can see the high power laser, the most important is the heat spreading. So we will increase the gold plating thickness to help the heat spreading. So typically they use the 1 micron thickness, but right now we use the 6 to 8 micron thickness to help our heat spreading. And after that, we do the lapping, then to do the end metal. Okay, so it's a very, very simple wafer process. And it's our CW laser. You can see it's our 100 milliwatt CW laser. It's a typically IV curve. Okay, so it's the different shape is the different temperature. Okay, so it's a very, very, so it's just to show we can reach the 100 milliwatt stabilizer at a 70 degrees C. Okay, so as I mentioned before, our top core technology is our stabilizer. So we use our DFB chip to develop our optical engine and also the LPO transceiver because we are not a tier one company, so we cannot get the DSP source. So it's not easy to get the DSP right now. So we all only can develop LPO transceiver. Yeah. Okay. We had a 400 gig and 800 gig optical engine. You can see our left side is a 400 gig optical engine. It's a 4 channel plan 100 gig. And you can see the left side is 800 gig optical engine. So you can see the two stabilizer, but applied to the one peak A channel. So later on, I will show the optical engines the step by step. Optical engine. So we first step is we die bonded our stable laser into the surmount. So it's a eutectic bonding into the surmount. It's the first step. Second step, we die bond another component, such as we die bond the peak, we die bond the lens holder, we die bond the COC into the transmitter side base. And after that, we put the isolator and the thermistor and the MPD into the transmitter side base. And the second, we will put the TIA and the PD array into the receiver side. You can see it's the receiver side fiber array is active alignment. And after that, because when we finish the receiver side, we will start to do the transmitter side. And right now we select the pick company that use the V glue solution. So right now we use the V glue to do the V glue is the passive alignment. So it's very easy to do the fiber attach and the high yield rate for us. So we select the V glue to use the V glue pick company. Then when we finish the TS fiber array with the empty connector, so right now you can see after that the final step is we use the alignment to do the TS length alignment. Yeah, it's the final process. And before that, we had finished the transmitter fiber array passive alignment. So you can through here to monitor the power level. So you can see when we do the TS side lens alignment, you don't know the power level. So but before that, we had to do the transmitter fiber array, so we can use this here to monitor the power level. Okay. So that's all from my side. Thank you.